Good morning students, welcome to online class DO Nalgonda. After complete the first section, next we are here to continue the second section. In first section, what did we learn means the classification of periodic table, classification of elements. The first atomic periodic, the first classification is Doberman triads, Newland's actors, Mendeleev periodic table, and the next one is modern periodic table. About the groups and the periods we learn in this last section. In this section, there is the properties. There is the properties, how it is varies in the groups and periods. Okay, atomic radius or atomic size. Okay, what is atomic radius or what is atomic radius or atomic size means the distance between the center of nucleus to outermost shell. Okay, atomic radius means the distance between the center of nucleus to outermost shell. That distance, that size is considered as a atomic radius. An atom, it has a nucleus, around the shells is there. So the last shell to center of nucleus size is atomic radius or atomic size. That is the atomic size. So how it is varies in the group and period. Okay. So for example, in group you see hydrogen, lithium, you take one group, first A group, hydrogen, lithium, sodium, potassium. Okay. So in group the atomic radius, here you see hydrogen 1s1, hydrogen atomic number 1, that is 1s1. Okay. So here center nucleus is there, in first shell 1 electron is there. So the size here nucleus to first shell. Okay, what about lithium 1s2, 2s1, lithium atomic number 3. Okay, lithium atomic number 3. So lithium atomic number 3 means write electronic configuration in by using Maillard diagram 1s2, 2s1. So center of nucleus, first shell 2 electrons, second shell 1 electron. So and next sodium atomic number 11, it has 11 electrons, 1s2, 2s2, 2p6, 3s1. Okay, 1s2, 2s2, 2p6, 3s1. Here you see it is the first shell, outermost shell, and it is 2 shells is there, second shell is the outermost shell. Here 3 shells is there, third shell is the outermost shell. So in group top to bottom. Okay, in group top to bottom the shells increases. If shells is increases, the size of the distance between the center of nucleus to outermost shell is also increases. So in group top to bottom, atomic radius increases. Atomic radius increases due to number of shells increases. Due to number of shells increases. Okay. So you take one group of elements as examples. First A group, hydrogen, lithium, sodium, potassium, rubidium, cesium. Okay. So go on down, the number of shells increases. First shell 1s, second shell lithium 2 shells is there, second shell is the outermost shell, and sodium 3 shells is there, third shell is the outermost shell, and potassium. So here nucleus, first shell 2, second shell 8, third shell 1. So total how many electrons is there here? So how many shells is there? 3 shells. Here only one shell, the size between the distance between nucleus to first shell, distance between nucleus to second shell, distance between nucleus to third shell. So go on, the shells is increases means atomic size automatically increases. So in group top to bottom shells increases, atomic radius increases. Okay, potassium also you see, for example 1s2, 2s2, 2p6, potassium atomic number 19 electrons is there in neutral atom, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So 1 first shell, second shell, third shell and fourth shell. Okay. So each period change means element shell is increases. So shell increases means the size between the distance between shell the center of nucleus to outermost shell increases. Okay. Next, in period you see ma. In period, in group top to bottom vertical column, in period left to right horizontal row. For example, you take a second period, lithium, beryllium. First period only two elements is there, they are hydrogen and helium. Okay. In second period lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay. So how it is varies in the period from left to right, lithium to neon. Okay. Here you see lithium, atomic number 3, 1s2, 2s1. Okay. Here beryllium, atomic number is 4, 1s2, 2s2. Okay. Boron, atomic number 5, 1s2, 2s2, 2p1, and this is 6, 1s2, 2s2, 2p2. Okay. Here you see center of nucleus, first shell 2, second shell is 1. Here first shell 2, second shell is 2 electrons. Okay. Here in boron, in case of boron, nucleus, first shell 2 electrons, second shell 3 electrons. Okay. So in this you take these 3 examples in a period from left to right. This in left to right these elements are same in period, same distance only. The electrons are entering into same shell, that is outermost shell, second shell. Here the distance between nucleus to second shell, here is also distance between nucleus to second shell, here is also distance between nucleus to second shell. But in the case of outermost shell, here 1 electrons is there, here 2 electrons is there, here 3 electrons is there. The number of electrons increasing means the attracting power between the protons and outermost shell. Same distance only, but attracting power is more. Same distance, same shells, the electron entering into same shells only, but the attraction power increases means they are come closer, the size automatically decreases. So in a period shells increases, so distance automatically increases. In group atomic radius increases due to the number of shells increases. But in the case of period, in the same shell only electrons are adding. Okay, electrons are adding. In the first, here same place, same distance only, here 1 electron, here 1 proton, 1 electron is there. Okay. And next, in the second element you have observed, here suppose here 2 protons, 2 electrons, 3 protons, 3 electrons. Same distance only, the number of protons and electrons increases means the attracting power increases. So if attracting power increases means they are come closer and they are shrink, the shells are little shrink, that is why the atomic size decreases in the period. Okay. In period atomic radius decreases from left to right. From left to right in same distance the attracting power increases. Okay, distance is same, but the number of protons in the nucleus and number of electrons in the outermost shell increases. So attracting power increases means they little shrink and the atomic size decreases. So this is about atomic radius. It is varies in the period and group. In group it is increases from top to bottom. In period it is decreases from left to right. Okay, and next ionization energy. Okay, next one is ionization energy. What is ionization energy means the energy required to remove the electron from outermost shell. Okay, the energy required to remove the electron from outermost shell. That energy is considered as a ionization energy. If more energy is required to remove the electron from outermost shell, more ionization energy. If less energy is required to remove the electron from outermost shell, it has a less ionization energy. So, here how it is varies this ionization energy in the period and group. Okay. First, the ionization energy in group. Okay, in group you see generally hydrogen, lithium, sodium, potassium. Okay, top to bottom, atomic radius what? Atomic radius increases. Okay, in top to bottom atomic radius increases. Why? Because shells increases, atomic radius increases. So, here nucleus to first shell electron, here nucleus to second shell electron, here nucleus first shell, second shell and 3 shells. Okay. So, go on in period top to bottom number of shells increases means the distance between the nucleus to outermost shell increases. If distance increases means the attracting power of protons on the outermost shell electron is decreases. So, the attracting power decreases means it is easily remove the electron from outermost shell. So, now you see in these 3 elements here nucleus first shell, here to here distance less is there means this proton effect on the this electron outermost shell electron is more. Nuclear attraction, nuclear is more attractive, more attract the outermost electron. In the case here the gap is more, the nucleus to outermost shell electron. So, here more increases to outermost shell to nucleus. So, the gap between the center of nucleus is a positive charge, the positive is if nearly is there means it is tightly hold the electron, if it is far to electron means it is easily lose the electron. So, here the distance is very less, so it is more attract the outermost shell electron. Here distance is going to increases means attracting power decreases, attracting power decreases means the electron outermost shell electron is easily lost. If it is easily lost means less energy is required. Okay. And hydrogen and sodium you have observed which is easily lose the electron? Sodium. Why? Because here nucleus to outermost shell electron more space, more gap is there, means attracting power less, is there means easily lose the electron. If it is easily lose the electron means ionization energy less required. So, the ionization energy in group from top to bottom decreases. Okay, ionization energy in group from top to bottom decreases. Okay, next in period you see. In period, the ionization energy from left to right. Okay, here you take lithium, beryllium, boron, carbon. Okay, lithium 1s2, 2s1. Okay, nucleus first shell 2 electrons, second shell 1. Beryllium 1s2, 2s2. First shell 2 electrons, second shell 2 electrons. Okay, next boron. Boron atomic number 5, 1s2, 2s2, 2p1. Okay, nucleus first shell 2 electrons, second shell 3 electrons. Okay, in period from left to right, the number of electrons increases in the outermost shell going from left to right. Okay, so the attraction between the nucleus to outermost in the same space only number of electrons increases, and number of protons in the nucleus and number of electrons in the outermost shell is increases in the same space. Okay, in the same space in the nucleus protons is increases, in the outermost shell electrons increases. So, the attracting power increases. Attracting power increases means this same gap. Okay, here how much gap is there means here is same gap, here is also same gap. In the same gap, but here only 1, here 2, here 3. Here 1, total here outermost shell 2 1, here compared to this and this, here 1, here 2, here 3 electrons. So, in the same gap here electrons and protons attracting power is increases. Attracting power if increases, not easily removes the electron from the outermost shell. So, it is not easily remove the electron from the outermost shell means it requires more energy. Okay, it requires more energy. So, in period ionization energy from left to right increases due to nuclear attraction. Okay, due to nuclear attraction. If nuclear attraction is more, electron is tightly binds with the protons, it is not easily removes the electron. So, more energy is required to remove the electron from the outermost shell. If nuclear attraction is more, ionization energy is also more. Okay. If nuclear attraction is less, ionization energy is also less. Okay. So, this like ionization energy in group decreases from top to bottom, in period increases in left to right. Why it is decrease? Why? How it is decreases in the group means top to bottom shells increases, the distance increases, the attracting power decreases. So, easily removes the electron from outermost shell. Less energy is required to remove the electron from outermost shell. Here in the same space, in the same gap, more number of electrons and protons in the shell, protons in the nucleus and electrons in the outermost shell. Attracting power is increases means more energy is required to remove the electron from the outermost shell. Okay. There is some ionization energy is affected by some factors. Okay, what are the factors affected the ionization energy means nuclear power. Okay, nuclear power. Okay, if nuclear power is more, nuclear attraction, nuclear power is directly proportional to ionization energy. If nuclear power or nucleus means positive charge, protons, if protons more attracting on the outermost shell electron, so more ionization energy is required to remove the electron from outermost shell. Less nuclear attraction on the outermost shell electron, less ionization energy is required to remove the electron from the outermost shell. And next, screening effect or shielding effect. Okay, screening effect or shielding effect. Okay, if suppose in any atom, first shell, second shell. If suppose another atom, if suppose the attraction of protons nucleus on the outermost shell, it is shielded by more number of subshells. So, the attracting power is not much in the outermost shell. So, it is easily remove the electron. So, if screening effect is more, the ionization energy is less. Okay. If screening effect is more, the effect of nucleus on the outermost shell, if it is objected by some screens and some shields, some subshells, so the effect of that nucleus is not on the outermost electron. So, outermost electron is not affected by that attraction of nucleus. So, it is easily remove the electron. So, screening effect is more, ionization energy is less. If screening effect is less, ionization energy is more. Okay. And next, penetrating power. In a shell, suppose fourth shell, okay, fourth shell has a 4 subshell, 4s, 4p, 4d and 4f. Okay. If suppose any electron is removed from the fourth shell, is it may be s orbital or p orbital or d orbital or f orbital. Okay. So, the 4s orbital are more penetrate than 4p, 4p is more penetrate than 4d, 4d is more penetrate than 4f. So, in any electron in the fourth shell, if it is in the s orbital is inside is there, more inside than the 4f subshell. Okay, here total 4 subshells is there, 4s, 4p, 4d, 4f. In these 4 subshells, 4s is more penetrate into the atom than 4p, than 4d and 4f. So, if electron in the 4f, it is easily remove the electron. Why? Because it is the outer areas, but in the 4d is little penetrate than 4f, and 4p it is little penetrate than 4d, and 4s is more penetrate than the 4f or 4d and 4p. So, if it is any shell is more inside in the atom, to remove that inside the subshell electron is difficult. So, penetrating power is more, ionization energy is also more. Penetrating power is less, penetrating it is deep inside the atom. Okay, if any electron in the deep inside the atom, it is difficult to remove the electron. So, more energy is required to remove the electron. So, penetrating power is directly proportional to ionization energy. Okay, next stable configuration. Okay, stable configurations are off-field configuration and completely filled. Okay, off-field configuration and completely filled configuration, the electrons arrangement is off-field in the degenerate orbitals or completely filled in the degenerate orbitals. At that case, the electron removing to disturbance the stability of that electronic configuration, it is difficult. So, if any element which has a off-field configuration by extra stability and which has completely filled configuration by extra stability, so from extra to disturbance the stability of that element, so that is more ionization, more energy is required to remove that disturbance of that stability of the element. Okay. So, stable electronic configuration of elements is required more ionization energy than other elements. Okay. So, these are the factors are affecting on the ionization energy. Generally, ionization energy in group top to bottom decreases, in period left to right increases. Okay. Nuclear power is more, ionization energy is also more. Okay. Screening effect. Okay, more screenshot objects the nuclear power to outermost shell electron. So, easily more screens is there means easily removes the electron. Screening effect more is there means ionization is easily removes the electron. If more penetrate, more ionization energy is required. Okay, next off-field and completely filled electronic configurations are stable configurations. To disturb that stability, we require more energy to remove the electron from the stability of that configuration. Okay, and next one, electron affinity. Okay, next one, electron affinity or electron gaining enthalpy. Okay, electron affinity or electron gain enthalpy. Okay, what is electron affinity or electron affinity? The energy liberated when an electron enter into outermost shell. Okay. Electron affinity, the energy liberated when an electron enter into outermost shell. In ionization energy, by removing the electron from the outermost shell, we required energy to remove the electron from the outermost shell. Okay. Electron enter into the outermost shell, it liberates the energy. So, in this case, in group, the electron affinity from top to bottom. Okay. Here you see hydrogen, lithium, sodium. From top to bottom, shells increases and lithium 2 shells and sodium 3 shells. The electrons in the group, electron affinity, the center of nucleus to outermost shell. Here in the hydrogen atom, center of nucleus to outermost shell, from nucleus to first shell, here nucleus to second shell and here nucleus to third shell. From top to bottom, shells increases means electron which is easily adding into the outermost shell means which is near the protons, which shell is near the protons, that is easily gained by the electron. Why? Because protons are positive charge, it is in the nucleus. This nucleus protons are attract the electrons in the outermost shell which is close to the protons nucleus. Okay. So, here from top to bottom, the distance of these protons to nucleus to first shell, here less is there, here more, and here more 3 shells is there. So, here more gap is there. So, in which case the electron easily attracting by the protons nucleus into the outermost shell means in the first case. Why? Because here the distance is less, so it is this protons are easily easily gains the electron into the outermost shell, it easily accept the electron into the outermost shell. So that's why from top to bottom the electron gain in the electron affinities decreases. Okay, electron affinities decreases. Okay, why? Because top to bottom the shells increases, the distance between the nucleus to outermost shell increases. Okay, nucleus proton power, positive power gap is more in the sodium. Why? Because here third shell and nucleus. So in the electron is adding into the third shell, it is somewhat the attracting power is not much on the third shell compared to attracting power of positive proton on the first shell. So that's why it is easily attracted. So energy is more liberated in the hydrogen atom. Here energy is less liberated in the sodium atom. So top to bottom, in which case electron easily accept into the outermost shell means first case. Why? Because here distance less, the nucleus positive attractive, protons are easily attract the electrons into the outermost shell. Okay, in period you see, in period electron affinity increases from left to right. Why? Because here lithium, beryllium, boron, carbon, nitrogen, oxygen, they are all one period. Here lithium you see 3 electrons, protons, first shell 2 electrons and second shell 1 electron. Beryllium 4 and protons, first shell 2 electrons and second shell 2 electrons. In the boron, protons, first shell 2 electrons and second shell 3 electrons. So here in the same distance, same size only, but that same distance, the size of the atomic size is decreases by attracting power of the protons to outermost shell electrons increasing in the same distance. In the same distance, the number of protons in the nucleus and electrons in the outermost shell increases means attracting power increases, atomic size decreases. Size decreases means the distance between the nucleus to outermost shell decreases, is going on from left to right. Okay, size decreases means the attracting power of protons in the nucleus is more effect on the outermost shell. So outermost the protons effect is more on the outermost shell. So the protons are easily gains the electron on the into the outermost shell. So this like in period electron affinity increases from left to right. Okay, in period, in group decreases, in period increases. Okay, and next electronegativity. Okay, electronegativity is the average of ionization energy and electron affinity. The electronegativity we can get, the capacity is average of ionization energy and electron affinity. Average means ionization energy and electron affinity of that element by 2. Okay, that is we can get electronegativity. What is electronegativity means? The tendency to attract the bonding pair of electrons, it has more electronegativity. Okay, for example, hydrogen and chlorine you see between these two there is a bonding electrons. Okay, these bonding electrons are more attracted towards the chlorine, less attracted towards the hydrogen, due to the chlorine has more electronegativity than hydrogen. In this molecule hydrogen and chlorine, the two elements, the two atoms, hydrogen is less electronegativity, chlorine is more electronegativity. Why? Because chlorine has a more power to attract the bonding pair of electrons, more strength to pull the bonding pair of electrons towards more its inside, more chlorine side, less into hydrogen side. So this tendency, this capacity is considered as a electronegativity. This electronegativity we can measure by average of ionization energy and electron affinity. Okay, the average of ionization energy and electron affinity is gives the electronegativity. Okay, what is electronegativity means? The tendency to attract the bonding pair of electrons more towards, it has more electronegativity. For example, hydrogen and chlorine, between bond, the bonding pair of electrons are more attracted towards the chlorine, less attracted towards the hydrogen. Why? Because chlorine has a more electronegativity. So in the total elements which has a more highest electronegative element is fluorine. It is value is 4.0. Okay. Thus electronegativity in group. Okay, in group the electronegativity decreases from top to bottom. Decreases in period from left to right increases. Okay. Why? Because electronegativity means electron gaining means it gets the negative charge. Okay. Electron has a negative charge. If it is gaining means it gets the negative charge. Electronegativity. Okay. So electron which is easily gains in group top to bottom, atomic size increases. So the distance between the nucleus to outermost shell increases. So more distance between nucleus to outermost shell means electrons is not easily gained. So that's why electronegativity is less in the group from top to bottom, but in the period from left to right atomic size decreases. The nucleus to outermost shell the size is distance is less. So less distance between nucleus to outermost shell easily attract the electron and easily gain the electron. So in period the electronegativity is increases from left to right. Okay. Next to metallic character the metallic character means all metals are electropositive elements. So the metallic nature left in group increases, in period decreases. Okay. And non-metallic character in group the non-metallic character metallic character increases and non-metallic metallic character increases in group and decreases in period. Okay. Non-metallic character in group decreases, in period increases. Okay. So these are the properties, they are varies with the period and group. Atomic radius, ionization energy, electron affinity, electronegativity, metallic electropositivity is opposite. Okay, electronegativity opposite electropositivity, and metallic character and non-metallic character. Okay. Suppose you see mass S black, P black and middle D black elements is there. At the bottom F black elements. S black elements are two, they are first A and second A. Okay, S black elements are two group elements, they are first A group and second A group. And P black elements are 6, it is inert gas, that is third A to 8th A. Okay, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, and middle D black elements is a, they are from scandium to zinc group of elements. They are third B to 8th B. 8th B is the group of three elements, group of elements, and first B and second B. Okay, at the last F black elements is there, there are total 28 elements, 14 are 4F black elements and 14 are 5F black elements. Okay. So these all black elements are, they are categorized by the electron is entering into the outermost orbital, the electron is entering into the valency orbital. Here you see S black. In this all elements the last outermost shell, the orbital you see it is s orbital. It may be 1s first shell or second shell or third shell in any shell, but it is the electron, last electron is entering to the s orbital. So s orbital it can accommodate only two. Okay, one is clockwise and one is anti-clockwise. Okay, that's why S black elements are only two group of elements, that is first A and second A. Okay, hydrogen, lithium, sodium, potassium you see. Lithium 1s2, 2s1, sodium 1s2, 2s2, 2p6, 3s1. Okay. So any element of this first A and second A group element, any element you see, the last electron is entering into s orbital. It may be first 1s, 2s or 3s or 4s. Okay. In the p black elements you see, all p black elements are the last electron is entering into the p orbital. That's why they are called as a p black elements. P black elements are 3rd A, 4th A, 5th A, 6th A, 7th A and 8th A group elements. So they are the inert gases, noble gases. Okay. 3rd A boron, 4th A, 5th A, 6th A and 7th A. Okay, any, if suppose boron you see atomic number 5, 1s2, 2s2, 2p1. Okay, so the last electron, the 5th electron is entering to p orbital. Okay, nitrogen atomic number is 7, 1s2, 2s2, 2p3. The last electron, 7th electron is entering to p orbital only. So it may be 2p, 3p or 4p or 5p. First shell not p orbital, the p orbital is start from second shell. Okay. And next to d black elements, scandium 21, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. The Euler diagram, by using Euler diagram, the energetic order we can easily write ns2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. The total number of electrons are 21. Atomic number, neutral atom atomic number is 21. So number of electrons is 21. 1s2, 2s2, 2p6 is 10. It is 20 and this one is 21. The last 21 electron is entering into d orbital. So that's why d black elements. Among these all elements you are observe, any element you take, that element last electron is entering to the d orbital. It may be 3d, 4d or 5d or 6d. And F black elements is also the last electron is entering to the f orbital. Okay, so that is 4 f orbitals are 4 is a 4f and 5f. Okay, so this is the sub classification of elements according to their blacks: S black, P black, D and F black. Okay, if suppose if any unknown element is given, okay, what is the position of element period? What is the position of element that in the periodic table? Group number and period number. If you want to say period number means you are keep it in your mind. The first alkali metals atomic numbers and inert gases atomic numbers. If you are keep in mind, so you can easily say that atomic number middle. Okay, so if given atomic number, it is comes which middle. So the element is under that period. Okay, if suppose groups means S black, P black, D black and F black. Okay, any element if it is given, that element atomic number if you know. Okay, that element atomic number if you know. Atomic number if you know means write electronic configuration. The last electron is entering into s orbital means either it may be first A or second A. If last electron is entering into p orbitals means it may be 3rd A, 4th A or 5th A or 6th A or 7th A. Okay, there is a resemblance 2s to 2p1 3 outermost shell valency electrons 3 and a third shell, third group. Okay, this group of elements all are resembles with 2s to 2p1, 3s to 3p1, 4s to 4p1, 5s to 5p1. Okay, how it will be means you see, for example, boron under aluminum is there. Boron under what element is there? Aluminium. Aluminium atomic number is 13. 13, 1s2, 2s2, 2p6, 3s2, 3p1. Okay, so first shell, second shell, outermost shell is third shell, 3s2, 3p1. Okay, aluminum after gallium is there. This is the 31 atomic number. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3D10 4p1. Okay, here you see this is gallium electronic configuration. By using molecular diagram we can easily write the electronic configuration of any element. Okay, the order you have to see 1s2 2s2 2p6, first shell, second shell, third shell. Here you see 4s and 3d. 3d is the third shell only, 4s is fourth shell, but while filling the electrons, first we have to fill 4s then 3d. Why? Because 4s is less energetic orbitals than 3d. So that's why 4s, how we know 4s is less energy than 3d? 4s to 3d10 4p1. Okay, up to here this is argon 18 20 30 31. Gallium 31 atomic number, it has 31 electrons, 18 argon, 4s2 3d10 4p1. Okay, here you see 4s2 3d10 4p1. While filling we have to use the half-bow principle. First we have to fill the electrons in the lowest energy orbital, then other. Okay, next one. So here 4s 3d10. In this 2, which is less energy orbital? 4s. How we can know? By using n plus L value in the half-bow principle. N plus L value observe in these two cases. Here n plus L value is, n is shell number 4, s orbital L value is 0 and n equals to 3 and d orbital L value is 2. So here 4 and here 5. N plus L value for 4s is 4 and n plus L value for 3d is 5. So in these two cases 4s is less energetic orbital because n plus L value is less, and 3d is more energetic orbital because n plus L value is 3d. 5. So that's why we are complete the first 4s, then 3d, next 4p1. But argon 3d10 4s to 4p1, fourth shell, outermost shell, fourth shell is resembles to 4s to 4p1. So that's like we can say it is third B, fourth B. Carbon aithe 4. Etla suppose carbon atomic number 6, 1s2 2s2 2p2, first shell, second shell. Okay, first shell, second shell, outermost shell 4 electrons, fourth A. Okay, 4 electrons, fourth A. If suppose carbon under silicon is there, 1s2 2s2 2p6 3s2 3p2. Silicon atomic number 14, 14 electrons is there, 1s2 2s2 2p6 3s2 3p2. So first shell, second shell, this is the third shell, outermost shell, 4 electrons is there. So it is under, comes under 4th A group. Okay, 4th A group. Here you see silicon after germanium is there, that is the atomic number 32. Germanium atomic number 32, 1s2 2s2 2p6 3s2 3p6 4s2 3d10 4p2. Okay, so first shell, second shell, third shell. Okay, this is argon. Okay, 4s2 3d10 4p2. So this 4s2 3d10 we have to write first, same like gallium. So 3d10 4s2. 4s2 4p2 means outermost shell. Up to 3 completed, fourth shell. How many electrons is there? 4. So 4 valence electrons means it resembles to 4th A group. It belongs to 4th A group. So this like we can say the outermost shell number of electrons how many is there means it is that group. Okay. So the s black elements, d black elements, the last electron is entering into d orbital, and p black elements, f black elements. Okay. In this section what it will learn means the properties of elements, atomic radius, ionization energy, electron affinity, electronegativity, and the separation of periodic table with the blacks, s black, p black and d black elements. If the element, if any element is position, if it is given, the position of element is known by periods and groups. Okay, periods means the first period, the period is start with alkali metals, ends with inert gases, and group numbers is we known by the valency and electronic configuration. If we are perfect in the electronic configuration, we can easily say that group number. Okay, electronic configuration by using Maillard diagram we have to practice. Okay, thank you.